Hello, we're here to present our new invention, Smart Automated Voice Recognition Wheelchair. My name is Nakyung Stella Lee, and I'm going to walk you through our product today. Our team consists of 5 members and is formed by sharing common interest in social contributions. While our team faced various barriers, most notably the initial setup of the motor coupler failing due to too much stress from weight and speed, we overcame them all to develop and complete our business plan. With our smart wheelchair, we advocate for the highest efficiency and performance of wheelchairs, a basic mode of transportation. With the mechatronic system and ability to self-navigate, we reduce the individual's dependence on external help and allow them for a greater mobile freedom. To optimize the cost of our products, a key partner is a current company that produces manual wheelchairs. Our company will benefit practically with more cost-efficient production process through this partnership. Adding electronic parts to an existing wheelchair is much cheaper and efficient, so we need an existing wheelchair business or producer to be a supplier. Financially, our critical financial resources include existing wheelchair businesses and government or external funds. We may need a patent for our smart wheelchair to protect our intellectual property. Our overall goal is to create an autonomous wheelchair that can sense the various road conditions and intelligently navigate the elders or the disabled people to their destination safely. To achieve this goal, we set 2 major objectives. First, build the wheelchair mechatronic system, and second, program the intelligence of the wheelchair to navigate the path by itself. Our business targets the elderly because they are mainly in need of wheelchairs. If customers want to purchase online, we will have a chat platform available that will enable them to learn more about our products and finally decide if they want to buy them or not. The Roll wheelchair is almost 3 times more expensive than our product while having similar technology, giving the advantage to our company. Hyundai Mobis will cost more than $5,000, and this astronomical price will make Hyundai Mobis and their wheelchair not easily accessible for most people with disabilities. We will pursue 3 channels to fund our initial setup and manufacturing process: private funding, family and friend, and online platform where we can market our vision. Now we will present our technical backgrounds. We chose a popular proximity sonar sensor CSR04 model with a detection range of up to 500 centimeters and a resolution of 0.3 centimeter. The sonar sensor operates by having an ultrasonic transmitter and receiver and calculates the distance of an object in front of the sensor by measuring the time for the emitted signal to return to the receiver. And our product combines these 2 key elements. The central hardware part of the product consists of the mechanical system and the electrical system. To incorporate automation into the smart wheelchair, we first equipped 2 BLDC motors on the frame of the wheelchair. Utilizing BLDC motors had significant performance merits compared to the regular DC motors because they had a higher initial torque and precise speed regulation. The motor mount was forged with stainless steel. This material could endure a vertical downwards force of a person's weight and stabilize the wheelchair experience to satisfy one of our initial goals of seating any person under the weight of 100 kilograms. This is the electrical diagram of the smart wheelchair. Now, with modular testing, we conducted motor tests with the BLDC motor, as shown in the video. During this modular testing, we encountered a problem that we could not reach the max RPM speed expected from the datasheet. Upon testing the motor to various speed using the potentiometer knob, we found that the initial electrical wires connecting the 24 voltage power supplied to the motor was too thin, and thin wires limited sufficient electrical current to flow, reducing the speed on the motor. So we changed the connection to the thicker wires and then observed the max speed of 82 RPM as expected. Sonar sensors, which provide distance reading from obstacles, provide information so that the wheelchair does not crash into the environment. 2D LiDAR is to help map out general area ahead and communicate to the elderly what the wheelchair sees visually. By far, creating a light mount that was still strong enough to sustain the weight was the hardest part of us. It took us more than 2 months to find the right balance between these two key variables as we went through many trials and errors. Now with the prototype testing, we conducted various experiments to evaluate the navigation algorithm of the smart autonomous wheelchair. Using its sonar sensors solely, we observed that the smart autonomous wheelchair could navigate around the room, making the correct turns and motions by itself. Building upon these materials, our team designed an algorithm for the smart wheelchair to navigate its way safely, avoiding obstacles. After initializing the serial communication, the program calculates the obstacle status from the sonar sensors by checking if any sensor readings were below 30 centimeters in front of the wheelchair. We also conducted experiments by placing the wheelchair closer to the corners of the room, as shown on the diagram, and observing how the wheelchair would react to not collide with those environments. These are the graphs representing desired behavior of smart navigation program. To improve this navigation performance, we plan to incorporate the 2D LiDAR sensor, which can provide a greater resolution of the distance readings in the future to improve the wheelchair's understanding of the environment. Thank you.